Here's number 36 from 2.1. It's a true-false question. If f of x is equal to x cubed plus x, then f prime of x exists for every real number x. Is that true or is that false? Well, let's take a look at f and maybe examine f prime. We might as well try to find the derivative, and maybe the derivative will tell us about whether it should exist for every real number x. So we know f prime is defined as a limit as h approaches 0 of f of x plus h minus f of x all over h. So in this case, that's going to be the limit as h approaches 0 of x plus h quantity cubed plus x plus h minus f of x, so minus the entire function x cubed plus x, and this is all over h. So let's expand and see where that takes us. This is the limit as h approaches 0. X plus h quantity cubed comes out as x cubed plus x squared h plus xh squared plus h cubed. Then plus the x and plus the h from the second term, and minus x cubed minus x from distributing the negative sign to f of x, and this is all over h. Notice a few things. X cubed minus x cubed forms a 0 pair. Those make 0. Plus x minus x, those form a 0 pair as well. And the remaining 1, 2, 3, 4 terms all share in common in h, so I'm going to factor that out. So this is limit as h approaches 0 of. H factored out leaves us with x squared plus xh plus h squared plus 1, and this is all over h, and that common factor of h cancels. So that leaves us with one more limit. The limit as h approaches 0 of x squared plus xh plus h squared plus 1. And we probably notice that as h approaches 0, the second and third terms will both become 0, and that means we have x squared plus 1 left over, and that means f prime of x, the derivative of f, is x squared plus 1. So the question is this existing for every real number x? And it does, because we can plug in any real number we want to that function, and all we have to do is square it and add 1, and we get the derivative. So this is going to be true, and we're going to say the justification is because f prime of x is equal to x squared plus 1.